Hi, I'm Shahar. I'm an engineer at StarkWare and the co-creator of Cairo. So I just want to talk about why we should use Cairo, what it does. Well, Cairo is Turing complete. From what I just heard, it has a lot in common with Zinc and zkVM, in the sense it also doesn't compile to a constraint system like the other things. There is only a single constraint system, a single error that verifies Cairo. And basically, when you compile your program, you just compile it to our VM is actually Cairo VM. Theirs is something else. But we took some different trade-offs when designing Cairo. Cairo is, I would say, a bit harder to use because it uses, like we saw before, field elements as basic types, and things are, your memory is immutable, and you have a functional-like language with recursion. But all these were designed so that it would be a lot more efficient. For each instruction, you get an overhead of about times 50 gates, which is a bit less than some other things. But I very much agree with what Alex said, that a lot of times the logic is a small portion of what you actually use. So if you have a lot of hashes, a lot of signatures, a lot of things that we do have efficient circuits for, then it might be negligible. Although there are some cases where you do want a lot of logic. In these cases, I think Cairo is a better option. But in other things, then it might be negligible. Okay, here are some numbers of its efficiency. We in F-Stark, which is the open source version, we can do over 10,000 hashes per second in a proving system. We did big batches of 600,000 means with very little gas. Like I said before, there is a single circuit, which means there is a single verifier, which is deployed today on Ethereum that everyone can use to verify every program. It's very easy to get started. If you want, just go to this link here, Cairo Lang, and you have the playground, which you just type code, press enter, it verifies, goes on chain. Just play with it. You have a lot of documentation. Just take a peek. It's nice. Other features which are nice is piggybacking on the big players like Immutable, DYDX, Diversify. Today they run on they use Cairo, and they use the shared proving services of Cairo, which you call Sharp. If you run today on Sharp, then you basically get the benefit of scaling from all of their big batches. Even if you have very small programs that you run, you get the benefit of their scaling. And other nice things we have are a lot of tooling and the IDE support. So this is an example of how Cairo code looks like. We have user-defined structs and types, functions, recursion calls, and dictionary accesses. Basically, what you would expect from regular languages. It is a special language called Cairo. It's more of a functional language. You, instead of loops, use function calls and recursion, and the memory is immutable. For better or worse, it's also a immutable memory. Actually, sometimes can make your programs a lot safer. This is an example of some of our tooling. Obviously, the compiler VM that you can interface with. We have the Solidity verifier that is deployed on-chain. You can use it today. Integration with IDEs, We have tracers, and we have a debugger actually today as well, profiler, and the playground you can see online. In the future, we plan to, there are currently projects working on compiling from other high-level languages, so you won't have to use the Cairo language in order to benefit from the Cairo VM and everything else. Plan to add the zero knowledge. It's already expressible in Cairo, the zero knowledge, just the prover right now doesn't support it, but we will plan to add it. A very big thing we want to go with is StarkNet, which is basically a permissionless general computation, L2 zk rollup of Ethereum. Okay, it's like Ethereum. Its security is based off of Ethereum because it talks to it, and you can publish your Cairo-like contracts. It will be a sort of dialect of Cairo with contract keywords that you can use as contracts and publish transactions like you're used to Ethereum and other things. And also additional built-ins. And built-ins let you do specific things very efficiently. Today we have Pedersen hashes in all of our projects. Plan to add other things like Ketchup. Today, Cairo is obviously live. We have a lot of projects running with it with a big scale. Diversify, Immutable, DYDX. This is our web page. This is our Discord. And I hope that was fast enough. Yeah, okay. Let's see.
That was very great. And there are a couple questions here. One of the questions was, how does Cairo check that a load instruction from a given address is actually the value that was stored previously?
Well, it uses a technique. I don't remember its name. We plan to release that white paper soon, but it works on a permutation trick that you have all the accesses on one side and all the sorted accesses on the other side. You prove it's the same permutation. And on the time sorted accesses, you can see that if it was previously accessed, then the next cell, which is the next access, is consistent. This is what we do.
Dare ask, what other high-level languages are you planning to support first?
Yeah, right now we are, okay, there are a few options. We are starting to work on going from things like Haskell or Idris or other functional programming languages because it feels more natural for Cairo. This is what we are undergoing today.
Bobbin was asking, what would be the overhead for prover time for executing a program with or without zero knowledge in Cairo?
There will be no negligible overhead. It's like adding a constant. Zero knowledge is just a matter of developing. It's basically adding a few random, strongly random values across the tree somewhere. It's not an efficiency multiplier.
Cool. Isaac asked for a link, so maybe that's something you can do after.
Okay.
And Jordy asked, maybe this is the last question, I think, and then we'll wrap up. But what's the current gas cost for verifying a Stark proof?
It's about 5 million gas, but it's mostly regardless of the size of the proof. So we have like, for example, in the example, the 600,000 mints, it was about 6 million gas, so 10 gas per transaction. If we put more things in the batch, it'll be less.
Got it.